Consumers want to know the facts about the products they buy, but America's agricultural landscape is not easy to navigate. Between different companies, scientific advancement, government regulations, advertisement campaigns, and an unhealthy amount of myth and misconception, anyone would be hard-pressed to make sense of it. That's where Real Ag comes in. From the producers who make your food, to the store where you buy the final product, and everything in between. This is Real Ag. Now, here's your host, Kyle Bauer.
We're all familiar with the different varieties of extreme weather in the state of Kansas. What qualifies as extreme? Are these types of storms becoming more frequent? We will answer these questions and more as we talk to a meteorologist, as well as the Science and Operations Officer of the National Weather Service of Topeka, on this episode of Real Ag.
Production of Real Ag is made possible in part by an underwriting grant from
the Kansas Soybean Commission, the Soybean Checkoff, progress powered by farmers.
What is extreme weather?
Extreme weather refers to rare weather phenomena that occur from time to time. You know, in a normal day when it's sunny and weather is relatively safe, we don't really call that extreme weather. That's more what we would call potentially normal, safe weather conditions. But every once in a while, we have rare event phenomena come up. We're talking about tornadoes, hurricanes, which are not going to be affecting us here in Kansas, except for the remnants occasionally. We're talking about tornadoes, blizzards, major fire weather patterns, ice storms, for instance. Those are examples of extreme weather that have the potential to produce deleterious effects on life and property. These rare event phenomena are very important that we forecast, message information about them so that people can put their safety plans together and then know what to do before the weather strikes.
Well, we would define extreme weather as basically anything that's way out of the ordinary, and that could be extreme heat, could be extreme cold, could be drought conditions, could be severe thunderstorms. Obviously not in this part of the world, but hurricanes. There's lots of different kinds of extreme weather, and I think sometimes we focus just on the extreme weather that's destructive, but we also have to think about temperatures and also storms too. So lots of different kinds of extreme weather that we see.
Are there markers that the Weather Service looks for in order to deem weather extreme?
Certainly, we can look at things in terms of deviations from normal. We can look at it in a statistical manner by looking at departures from average over 30-year-long return intervals, for instance, and see how many degrees in terms of temperature we are off. But then for more weather type events, such as severe weather events, we're able to consider climatological departures from normal, or rather departures from climatological normals. We're at a time of year right now in May where we're dealing with relatively higher climatological values or probabilities of severe hail, wind, and tornado occurrence. And when we expect there to be much higher on a given day-to-day basis probabilities of severe weather, we would deem that to be, based on the meteorological factors that govern the severe weather threat, much above or potentially below normal. And then ultimately, whether or not we are at some deviation level from a normal probability or a normal temperature, we got to think about the impacts. Even if the probability of a tornado is 2% today and the climatological normal is 2%, if that tornado strikes someone's house, that's an extreme event regardless. That is going to have major effects on life and property, even if it's within the realm of what's considered normal from a probabilistic manner. So we got to really differentiate between the impact and what's climatologically normal, because when we talk about extreme weather is never normal, but we can still provide some statistical assessment of what is going to be more occurring on an average basis.
There are definitely certain definitions that they will label certain extreme events with. For example, when it comes to thunderstorms, we would classify an extreme storm perhaps with hail that's quarter size or 1 inch in diameter, or wind speeds of 58 miles per hour stronger, or obviously a tornado. And you only need one of those three for it to be classified as a severe storm. So there are certain definitions. When it comes to a blizzard, you're supposed to technically have visibility under a quarter of a mile for 3 hours continuous, and if you don't have that, then it's not technically a blizzard, even though most of us have been in situations where it could be 20 minutes of whiteout conditions, and that would be pretty extreme. So we have definitions that we attach to certain extreme events, but I know each individual on their own will sometimes have a different definition of what an extreme event will be. But when it comes to meteorologists and how we work together dealing with different events, we have our own different definitions of extreme weather, but we have to follow the National Weather Service guidelines, and so that's what it is. You know, it could be severe thunderstorms, hurricanes, those types of things, but there are definitions of extreme events.
Is extreme weather increasing, or does it vary from year to year?
The thing about extreme weather is that because it's so rare, it varies so much from year to year. We'll see some years when we have tornado outbreaks across the country, quite frequently concentrated in parts of April and May, and then another year when it's not. But we see a lot of variability from year to year. And when we take a step back and we look at the entire period of record for which we have a severe weather, temperature, for instance, over the last several decades, what we tend to see are a lot of high degree of fluctuations from year to year in terms of the types of weather that we encounter. So extreme weather is something that varies a lot from year to year, and so that's the bottom line point, is that everyone needs to be ready for extreme weather, have a safety plan prepared, practice that plan, and then put that plan into place when extreme weather is forecast, and be able to receive that information.
What qualifies as a watch or warning?
A watch means that atmospheric conditions are favorable for the development of the phenomenon in and close to the watched area. Persons in these areas should be on the lookout for threatening weather conditions and listen for later statements and possible warnings. A warning means that the phenomenon, the weather, the severe weather for instance, that it is imminent, it is likely happening, or it definitely is happening. The watch means that you need to review that safety plan, be ready to take that safety plan into action when that watch comes out. That means that conditions are favorable over the next several hours. We talk about winter storm watch. It could be over the next couple of days. And when the warning goes into effect, we're talking about immediate effects to life and property from hazardous weather, such as severe thunderstorms, ice storms, for instance. That means that you need to take that safety plan and put it into action because that weather element is imminent.
Who decides when an area is put into a watch or a warning?
When we're talking about severe thunderstorm and tornado watches, those are issued by the National Weather Service Storm Prediction Center in Norman, Oklahoma, when they deem that the atmospheric conditions are favorable for the development of severe thunderstorms and or tornadoes in and close to the watch area. They'll outline an area of what we call a watch box area that then is coordinated with a local National Weather Service weather forecast office, such as the one here at the Weather Service in Topeka. In fact, the last few days we've been in collaboration with the Storm Prediction Center for those watch boxes. And each of the offices that are affected by that watch area are coordinated with for those severe thunderstorms and tornado watches. However, when we're talking about winter storm watches, for instance, flash flood watches, those are all issued specifically here at the local forecast offices. When we talk about warnings, those all come from here at the local forecast offices, at the local National Weather Service weather forecast offices. When we see that based on radar data, environmental conditions, spotter reports, other observations that we're dealing with imminent, occurring, or very likely to occur hazardous weather, we will issue those warnings to indicate that those hazardous weather conditions are indeed imminent and people need to take their safety plans and put them into action immediately.
Is climate change to blame for the recent change in temperatures, lack of snowfall, rain, etc.?
When we talk about climate versus weather, I like to think of a baseball analogy. So when we think of climate, I like to think of a batter's average performance, for instance. When we talk about the weather, we're talking about how that individual batter performs when they're actually up to bat at any one given time. So the overall culmination of the different weather phenomena is what we're talking about when we talk about climate. The individual events themselves, that's the weather, just like the batter's average performance, that's analogous to climate, just as how they perform when they're up to bat, that's like weather. So each individual element of the entire integral of all the processes that go into climate are going to all comprise what climate is. However, you can have major deviations from normal and still have that fall within the broader climate aggregate, for instance. And so what we're talking about, a long-term average, it's really composed of all the different pieces that come together over time. And there's a lot of things to explore in terms of how that average interacts with each of its subcomponent pieces. And the main point here is to always be ready for the very large degree of variability of weather phenomena, as you can have a typical long-term trend that is not necessarily representative of the individual extreme weather impacts.
The answer to that would be both yes and no. You know, I run into a lot of people that say we don't get the big snowfalls that we used to some 30 or 40 years ago, and I think to some degree that could be linked in with climate change that's happening, you know, around our world. But for example, the recent extreme heat that we've seen in the West, you know, sometimes we want to tie a week or two of very hot weather to climate change, and you just can't do that because weather, you know, everyday weather we think of as sort of a chapter in a book. Climate would be the entire book. And so we want to link some of the extreme weather events that we see day in and day out to climate change, and you just can't do that. And one of the things that can be frustrating for a lot of meteorologists is everybody wants to take an extreme event and tie it to climate change, but in all reality, our weather has been extreme for hundreds of years. And now that climate change makes the national news, we want to just link all of these big events directly back to climate change.
How is information mainly distributed?
There are many methods of the dissemination of weather information such that we're able to get our watches and warnings, advisory information out to our customers, our partners, the public at large. For instance, a very important source is NOAA All Hazards Radio, which is operated by the National Weather Service. In the individual offices, you're able to have a NOAA weather radio and get the latest information that will be interrupted with what's called the specific area message encoder tones that will then activate the NOAA weather radios when there is watch and warning information. That's a way to get that latest hazardous weather information immediately up to date. If it's in the middle of the night and you're sleeping, you can't hear the sirens, for instance, that will be very much analogous to like a smoke detector, except for hazardous weather conditions. But there are many other methods. We're on social media, so whenever, if you're on Twitter or Facebook, for instance, we'll be pushing information out through various messaging techniques, and providing graphic casts, for instance, providing information about active watches and warnings, for instance. Also, if you go to our website, weather.gov, and click on Northeast Kansas, for instance, you'll be able to get all of the different forecast informations, event summaries as well. As far as other ways of getting information, our media partners are able to also take our information and provide that to the public at large, for instance. Those are all examples of ways in which that information is provided.
Where is past weather data stored?
The National Climatic Data Center back in Washington, D.C., I believe, they basically keep all of the weather records. And so it doesn't matter how big or how small the town or community is, if there is an observer there keeping weather records, all of those are housed in that particular facility.
Who reports weather data?
It could be a farmer or rancher that has a rain gauge and they write down when they get rain, when it happens, and they fill out a monthly report. They submit that to the National Weather Service, who then turns around and submits it on to the NCDC, is what we call it, and they are the ones that log all of those records. They're called cooperative observers, and so their job, some of them report temperature, high and low, but mostly the cooperative observers are just recording rainfall, and those bits of information then are stored back in the east.
Is it more difficult to predict certain weather?
The most difficult weather, I believe, to forecast is snow, mostly because within a mile or two you can see a dramatic change in how much snowfall occurs over a particular area. But then aside from that, it's also how people measure. Some people will measure in a ditch or a snowdrift and claim they had a tremendous amount, when in all reality it's maybe not that much. So snowfall is the most frustrating thing we have to forecast. Second would be rain events, thunderstorms too. But day-to-day weather, we have a pretty good handle on it now with the technology that we have, forecasting the high for the day, the low for the day, the sky conditions, the wind, all that's fairly manageable, but precipitation events are still by far the hardest.
Do you see the weather issues or patterns that we didn't see even 5 years ago?
Certainly as we move forward in time and we're able to sample the atmosphere, model the atmosphere in more sophisticated manners, we're able to learn more about the different physical details that drive the weather that we see. That allows us not only to understand the weather phenomena in a new light, but also make predictions for the weather that are going to be substantiated on even more of a foundation of information. That's really what we call research to operations, as we develop our toolkit and our knowledge, our tools and resources of how the science works. We're able to address a lot more of the challenging problems. And these developments occur on the time scale of years, decades to years to even months. And so we're always learning more and trying to improve our capabilities in terms of forecasting and messaging hazardous weather conditions.
Are there government agencies that are involved with the National Weather Service?
There's certainly many different organizations that we collaborate with. For instance, geographic area coordination centers collaborate with the National Weather Service from fire weather perspective. We're definitely outside the realm of collaboration, but in terms of partnerships, very much work with federal, state, local levels of emergency managers, for instance, in terms of being able to get that information. We want to make sure that the information that we're providing in terms of past storms is the most correct that we have, and so we'll perform storm surveys, for instance, such that we're not releasing information out before we actually have some more finality into what we have or what we are documenting in terms of that hazardous weather. We are certainly beholden to all of the laws that are out there in terms of information release, making sure that we are providing the most accurate information that is founded on a complete survey of information that takes into the multifaceted approach to understanding what happened, both weather-wise, the environmental conditions that went into play when governing what actually happened at the ground. And so we're always doing our best to make sure that we're getting the most accurate information out there at all times so we can fulfill our mission of protecting life and property.
Most of the department that we are involved with when it comes to government is the Department of Commerce, because the National Weather Service falls under that branch of the federal government. And so, the important thing for us is that they continue to fund the National Weather Service appropriately with enough money that we can continue to see advances in technology. But, they reach out to a lot of their partners, and being in the broadcast sector, working with them, we want to make sure that there's ample money there so that they can continue to do the things that they need to do, but also in working with us so that we can reach out to the public and educate people on severe weather events, changes in technology. But it's very important from a government standpoint that, most importantly, there's funding there for future research. And so that's really important.
How are weather spotters used to detect extreme weather?
Certainly having spotter training is a very critical way of understanding the different phenomena that we are looking to have documented at the ground. As you can see from these radar images in the background over here, we're looking above the ground when we're talking about the hazardous weather phenomena that we're trying to anticipate. So the spotter plays a very key role in providing the ground truth. That's the weather phenomena that are occurring at the ground below the points that you're seeing on this map that are being sampled here, so that we know what's actually coming out of these storms and we can get ahead of them in terms of getting the warnings out in advance, for instance. And so, or confirming our notions of what's happening at the ground based on the environmental factors that go into governing these storms that we're observing from radar. So the spotter's knowledge of various cloud features such as wall clouds, rotating wall cloud, shelf cloud, what the implications are that in terms of storm hazard, intensity, is going to be absolutely key. So having that knowledge by going to spotter training courses is critical so that we can get a very consistent set of information that we are trying to use and to incorporate into the warning decision-making process. However, certainly reports from anyone at large, we appreciate them. Just provide as much precision and accuracy to those reports. For instance, whether or not you attend a spotter training course, and if you experience hail, if you let us know on social media, for instance, or give us a call, that information is great. Make sure it's very accurate and precise. So, saying marble-sized hail, marbles come in all different varieties, very different shapes and sizes, and so comparing something to a standardized feature like a coin, for instance, or a tennis ball, for instance, or a golf ball is going to be very critical so that we can correlate what's happening at the ground to what we're seeing on the radar and in the environmental conditions. And so anyone can provide those reports, but we encourage everyone to attend spotter training so that you can have the greatest amount of education into the types of information that we're looking to gather when understanding what types of storm hazards can come out of what we're sampling here from our radars.
How does someone get into the field of meteorology?
It's a great question. Certainly a college degree in atmospheric sciences and meteorology is absolutely imperative in terms of becoming a meteorologist in the National Weather Service. Getting as much experience in communications, in computer coding, in science, research development is absolutely key. Many individuals in the National Weather Service have also gone on in terms of completing a graduate degree, although that is optional, it's not required, but that's another way of getting additional research in order to be able to apply the research into operations, for instance, which is very key in terms of bringing the science forward. But that can be done by absolutely anyone, and so getting that strong scientific backbone is absolutely critical, no matter what level you have, whether it's a bachelor's degree, a master's degree. Myself, I completed my PhD at the University of Oklahoma, and that for me has been very helpful in terms of being able to cultivate research knowledge and then operationally implement that in terms of specifically severe storms. But there's a multitude of different backgrounds, a diversity of different backgrounds where we're all contributing, but the baseline level of understanding is certainly that bachelor's degree in meteorology or atmospheric sciences. There are many universities throughout the country that provide those accredited programs, those degrees, and certainly getting experience as a volunteer or a student pathways intern in the National Weather Service is very helpful in terms of picking up those skills, tools, and resources to become a meteorologist in the National Weather Service.
How has weather detecting technology changed over the years?
We've seen some dramatic changes in just the last 5 years. For example, the radar technology has changed such that we no longer have to wait 6 minutes to get a new picture of a storm. We can get new images every 2 to 3 minutes. In satellite technology, we just put a new satellite up about 2 years ago, and now we can get satellite pictures every 30 seconds to 1 minute. The modeling technology that we use to forecast events has changed significantly, so we're getting new model information every 30 minutes to every hour, and that helps us get a better definition on where storms are going to start, when they'll end, how much rain we're going to get. So lots of changes in just the last 5 years.
Is there follow-up that is done after extreme weather incidences?
Yeah, we definitely go back and we study past events because there's a lot to be learned from, going through an event. First of all, from a warning standpoint, what could we have done differently? What did we miss about this event? What did we do right? What did we do wrong? And so meteorologists, both those that issue warnings and those that are forecasting, go back and look at past events to see what opportunities were missed. Because like anything else, you learn from your mistakes, and we hope that they're not glaring mistakes that result in fatalities or something like that. But weather changes very, very quickly, and so we have to be on the cusp of that. And so it's best for us to look at past events, learn from those, so that when we see ones in the future, hopefully we're just that much further along and ahead of Mother Nature.
Are there laws that have to be followed for the National Weather Service?
There are some certain rules that they are tied to. For example, we actually have a chat room now where we can communicate directly with National Weather Service meteorologists during severe weather events. But for us to ask them specifically if they're going to issue a particular product, issue a watch or warning, sometimes they're not allowed to give us that kind of information. So they have certain rules that they have to follow. And when it comes to watches and warnings, again, they have certain rules where, like with a particular warning, they can't cancel that within 10 minutes of expiration. So certain rules are a little bit frustrating to work with. And if there's one thing that's a little bit frustrating within the sector of the National Weather Service is that they're trying to make it a one-size-fits-all. Well, how it works in the plains is going to be very different than West Coast and East Coast. And so we're hoping that down the road we'll move to more regional sectors where here in the plains we can do what we need to do, while those on the East and West Coast, they can handle things a little differently. So maybe 5 or 10 years down the road we'll see a change in the rules that allows us to have a little more flexibility. But for right now it's really a one-size-fits-all in the National Weather Service.
Extreme weather can come in many different varieties here in Kansas. The collecting, storing, and studying of these weather patterns are essential in helping us to understand and predict such phenomena. We hope this will help you gain a greater understanding of what goes into the studying and predicting of extreme weather. Don't forget, if you want to check out this and other episodes of Real Ag, go to SmokyHillsTV.org. For the Real Ag crew, I'm Kyle Bauer, and this has been Real Ag.
Production of Real Ag is made possible in part by an underwriting grant from
The Kansas Soybean Commission, the Soybean Checkoff, progress powered by farmers.